So far I took the function. I know A is my y-intercept, so A is going to be 20. They gave me a point, x and y. I plugged in x, y, and a into the function, and I had 4 equals 20 times b to the fourth. Divide by 20. 4/20 is 1/5. And then I'm taking the fourth root of both sides. Okay? So I end up with b on this side, and on this side, I still just have the fourth root of 1/5. Now, if you put the fourth root of 1/5 in your calculator, you're going to get some kind of crazy decimal. Okay? What they're expecting us to know right here is, remember when we talked about how to rewrite rational exponents or fraction exponents as radicals? Remember, the base is your radicand, which is x, power of 1 is the numerator, and then this would be an index or root of 2. So it's just working in reverse. If I have it written like this, can I go in that direction? And of course you can. So you take your 1/5 in parentheses, because we're going to do it to a power. The power would be 1/5 power would be 1, right? There's no power in this, it's just assumed to be a 1, over the index of 4. So I now have everything I need to plug in. Y equals, or g of x equals, a times 1/5 to the 1/4 x. That's the answer. And don't forget, 1/4 times x is the same as x over 4. Those mean the same thing. Okay? So, and I always say this to you, and I mean it, let the multiple choice questions work for you. And we say this on the SAT and ACT also, you guys. If you can narrow down to 50%, take a guess. Okay? Not that we want you to guess, but you should have eliminated C pretty early on for a lot of reasons, right? It's oddball and it's not the same A value. And then hopefully we didn't look at this and think, oh, I must have just done something wrong. Maybe 5 is the same as 1/5. There's that fourth root in there. No, we can't make that kind of a stretch. It had to be one of these two. So does it make more sense for it to be x over 4 or negative? So it's this one. All right. So you know, I don't trick you guys. When you take your test, you should know that number 3 on Friday's portion is going to be something that looks like this. You know, I don't try to trick you. I'm not trying to catch you. I'm trying to make you learn something and then remember it. Okay? All right. So that's 3. Questions on 3 before I do 6? Good on 3? Okay. Number 6, it says Denise earned $24,500 during her first year. That's code for A sub 1. That really matters, guys. That's not a y-intercept. That's not A sub 0. It's A sub 1. When you see that, you know you're not using this formula anymore. This is not that formula, because this is A sub 0. This is your initial bacteria amount, your y-intercept, starting amount. This is A sub 1. Okay, it said it almost exactly. It also gives us a rate. She's getting a 4% raise. So we know we change our percents to decimals. Be careful moving that decimal point. And it's a raise, so don't forget to add 1 to it. So that would be 1.04. And then it says, how much did she make in her 5th year? And because of this 1, and just because of that 1, we know we're using this formula. It matters. It matters. Okay? So keep that in mind. A sub 1 is the geometric explicit formula. A sub 0 is your exponential function. They're super close, because B and R mean the same thing in both equations. Right? It's just which one are we working with. And so we would just do A sub n equals 24,500 times 1.04. 5 minus 1, which ends up being 4 in your calculator. You would get a different answer if you used this formula and plugged a 5 in there. It'd be off. And I'll tell you, when you do this on the test, well, let me finish this one. This answer, when you do it in your calculator, gives you that. This was something I had them fix yesterday, Gavin and Sammy. You might want to just fix that. So that's the answer you'll get in your calculator. And there's no other answer that's even close to it. So if you had messed up on this problem, plugged in a 4 or a 5, you would have had the answer would have been closest to this and probably guessed it. But on the test tomorrow, one of the choices is of course, the right answer, and one of the choices is going to be the answer if you plugged in to the wrong formula. So it's going to be really close. It's like 28,000, blah, 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 and 29,000. It's a difference of like plugging a 4 in or a 5 in. So you have to know that it's this formula, okay? Because of the a sub 1. That's what I said. This formula uses a sub 1. The exponential formula, even though we don't write it, it is a sub 0. It's your y-intercept, your initial amount before time has gone by, like in a word problem, things like that. This is how much she made after her first year, a sub 1, okay? Number 9 is calculator steps, so I wanted to make sure you guys remembered how to do that. Number 9 and the FRQ. So number 9, I would just do this with me real quick, just to remind your fingers where the buttons are. I would go ahead and clear your RAM. Always do that. When you pick up those calculators, I would always clear the RAM, okay? And then this is, it gives you a table of values, and it wants us to use it to predict 2.5, the y value when 2.5 is x is 2.5. And it gives some hints in there. There's some words in there that kind of give us a hint. Exponential regression, okay? When you hear regressions, that's when we're finding a line of best fit. And that's when we go to stat, edit, so just stat, enter, and that's where you type in your x's and your y's. So if you're doing this with me, which I recommend you do, go ahead and type your x's and your y's in. I'll give you a second to catch up to me. Don't ask me on test day, where do I put that? This is the time to be practicing that. And doing it with your fingers right now is going to help with muscle memory. Okay? Rex, Kylie, you guys are good with this? You don't? You're good? Okay. All right, so once you get your X's and your Y's in, and I would even take an extra second on a test and make sure you didn't make any mistakes in there, right? It takes a lot of time to go back and figure out. Just double check, did I type it in right? I make mistakes doing that all the time. All right, then we go to stat again, over to calc, and we want exponential regression, exponential. And you can scroll through till you find it, or you can just remember it's 0, okay? 0 is exponential regression, okay? So it gives you this screen. And we have to decide, do we want to put our alpha trace enter in or not? And the answer is on this one we do, because if you look ahead, we're going to have to use the table of values. So if you're not sure, just go ahead and put it in. It just might be a good thing to do every time you get here, which is alpha trace enter. And remember, that's just saving it in the brain of the calculator. Alpha trace enter. And then just keep going, and that will give you the function. Now, in this example, we don't care about the function. It didn't ask for what A and B are. So I'm not even going to bother with it. I'm going to go right to my table. And my table is going to give me, from negative to positive infinity, all the y values. I want 2.5. But remember, your calculator by default counts by intervals of 1. And so I already lost it. Can I just hit plus now? Yeah. So when you hit the plus button, it gives you the change in table. That's what that means, change in the table. You can see right now it's just 1. That's telling you it's counting by 1s, right? We want it to count by what? 0.5. So we just hit 0.5, enter, and it just quickly and easily changes to count by 0.5s. So we want to go to 2.5, and you'll see the answer is closest to this. And the reason we're off is because I'm pretty sure when she made this key, she actually wrote what the function was, whatever it was, but wrote the A and the B and rounded, and then actually plugged 2.5 into that, got the answer. That's why they're a little bit off. But I checked the one on the test. Using the table, find the one closest to it, and you'll be fine. It's going to be off by maybe a couple tenths or hundredths of a decimal, but that is the closest one to 868. Okay? Are we good on number 9? You know number 9 on Friday's test will look just like that. Okay? Last, let me just go over the FRQ with you. Okay? This is the one a lot of people just like, I'm not ready to do the FRQ. I'm just going to ask her for help on it later. No. Okay, so I'm almost done. After I just explain this FRQ, which is not hard, after I explain this, I'll stop talking and I'll come around and help. Okay? So let me sum this up for you, because no tricks here. On Friday, this is what your FRQ is going to be. It might not be ladybugs and Asian beetles. It might be whatever and whatever, but it's going to be a similar problem, okay? And these, what it says up here, are the models of the population of these nasty bugs at t equals 0 days, okay? So t is the number of days, and so the first question is, what's the initial population? So that's when x is 0. So you could plug 0, or t is 0. You could plug 0 in your calculator here and here, but remember, it's always your a value. That is a sub 0. These are exponential functions. So your initial amount is 2,000 and 3,600, also known as your y-intercept. So there's no really work you have to do for that. The next 3 are all intersection problems. Let me tell you why. How many days will it take the ladybugs to reach 5,000? That's the intersection between the ladybug formula, L of t, and y equals 5,000. I'm going to do it in a second. C is how long will it take the Asian beetle population to be cut in half? Half of what? Half of its original amount. So half of 3,600 is 1,800. Okay? So you'll do the intersection between B of t and 1,800. And I'm going to show you all this. I'm just going over it. And then the last one is finding the intersection between both of the L of t and B of t, because that's where you'll find they have the same number. How many days will it take for the population of one to be the same as the population of the other? So wherever they cross, that is the number of days, okay? So I have a way of making this a lot less work for you, so if you want to stay with me, you should. So go ahead and clear your RAM again, because we just put a bunch of data in it. And intersection, we've done a lot in here, and I don't think anyone's really confused about how to do intersection. It's the window on this one that's a little, all right? So, as we said, part B is finding the intersection between L of t, which is this one, and 5,000. So I'm going to type in my L of t function, 2,000, and if you're looking for the E button, it's above natural log. Right here. Okay? And when you use it, it gives you the E, and it puts your cursor right up in the air for you, 0.025, and of course we'll use X instead of T. Right? So just take a quick second, and make sure you typed it in right. I typed it in wrong first period. My graph was a mess. I had to go back, then the bell rang. It was a mess. I cried. I didn't really, but I wanted to. All right, so that's L of T, and then 5,000 would be your second equation. Y equals 5,000, horizontal line at 5,000. Now when you graph this, Sorry, say it again. Look at the question, part B. Yep. All right, now when you graph, if you did it right, you shouldn't see anything. You're not going to see anything because your calculator, if you go to window, it defaults to 10 in every direction. We have to be at least as high as 5,000. We're only at 10 right now, okay? So you can play with this as much as you want, okay, depending on how much time is left on the test, right? You don't want to spend too much time on it. But like if you wanted to just zoom into quadrant 1, for example, you could make your min values for X and Y both 0. That is completely unnecessary. I'm just talking to you, okay? If you wanted to zero in and just have quadrant 1, if you make those both 0, then we get rid of those. But you didn't have to do it. It would not have affected your answer. Just kind of giving you that. Y max, think Y equals 5,000 right now. You want to be above 5,000. So maybe 6,000. Is that the only answer you could put in there? Absolutely not. 7,000 would probably be fine. 5,500. You want to be above 5,000. Okay? The X max is the hardest one. We know the answer because we have the key, right? But you wouldn't know that ahead of time. And so let me just show you what you might do. I'm trying to think like you would think, like I would think, honestly. If that's really big, maybe that's really big. So maybe I should put in like 4,000 or something. You might be guessing a little bit here. Or you might actually say to yourself, you know, would it take 4,000 days? I don't know. I usually don't get that big of a number. But it's okay. Let's see why that's not a good answer without knowing the answer. Why that's not a good X value. Because what it's going to give us momentarily is it's giving me the Y equals 5,000 because I went high enough, but I'm not seeing where the other graph is. That's because, guys, look, my X value is 37. This is way too big. All right, so when you don't see the other graph, you got to change something. And since I know the Y max is fine, I can see how high that is. I know the X max is wrong. And you might just not know what to do. Maybe you put 1,000. Do I see it now? Oh, I'm starting to see it, but I'm still a little too, I don't know. I get confused between zoomed in and zoomed out. Like, I could probably find the intersection there, but it's a little tight. So I might even go a little bit further. Maybe I change it to 500 or 100, whatever, okay? You have to be able to see the intersection. And just for the purpose of teaching, I'm going to just change it one more time to like 100, just so I can just give us a bigger picture to look at. But that last one probably would have been fine. Because the reason what we have to see is you have to be able to get your cursor on both sides of it. Okay, now I can see the intersection. Here's the good news. Once you change the window for this one, you're good for the other two. You won't have to do that again. You'll be in the right vicinity. All right? Okay, so now we go to intersection, which is second calc, and then number 5. And a lot of times I don't know where my cursor is, and I'm being totally honest. I start to panic almost. Like, wait, what, did I do something wrong? Don't panic. It's usually way up high, so I just hit my left arrow button until it comes into view. It will come. Be patient. There it is. Okay, and you just want it somewhere on this curve. It doesn't matter where. I can go way down here and hit enter. I can go way, any of these places that I'm moving the cursor are perfectly fine. Hit enter. And it like stamps it right there. And then it moves the cursor, for whatever reason, onto that horizontal line. So think of it as we already have a point to the left of the intersection, right there. Now we're just getting somewhere to the right. It doesn't matter where. Okay, here's fine. I can go further away. Hit enter, and then remember it's going to say yes, and you hit enter one more time. And you're going to get 36 point something there. So don't write your answer as a decimal, and don't use rounding rules necessarily. This would be 36 days and then part of another day. So that would be 37 days. On the 37th day is when this will happen. The day's not over, but sometime on the 37th day it happens. Okay? And you're going to do that for all of these, but I want to show you a quick shortcut to make your life a little bit easier, because if I do part C next, look, if I go to part C, I'm going to have to go back to y equals. I'm going to have to erase both of those and type B of t and 1800. Okay, 2 different equations. How about go out of order? Let's do the last one first. I already have L of t in there, so I only have to erase the 5,000. So I just hit clear, and then I can just type this one in. It's okay if you go out of order. It's just less typing. Less typing equals fewer chances for mistakes. Okay, so take a second, double check. Do I have all the decimal points in the right places and everything? But like I said, when you graph this, your window's you've already put the window in the right area. So you should be able to see the intersection without having to do any extra work. So intersection here, second calc 5. Find your cursor. Where are you? There she is. Come on down here. And look, let me show you. You don't have to be on the left side first, as long as you're on one of the sides. Like I can start there, if you can see. I can start there. That would be my first curve, fine. And then over there would be the second one. See, I have one on either side. It doesn't matter which one's first. And then guess gives you 10 point something. That's 11 days. Okay. Then go back and do part C, because we want B of t, which is the 3,600. So we can just erase y sub 1 and put 1,800. It's okay if it goes first. It doesn't have to be the second equation. As long as they're both in there, it doesn't matter what order. Okay, so I already have that typed in, so I just change the top one to 1,800, graph, and then do your intersection thing again. Okay, so it's the same thing a bunch of times. Like, I'm going to hit enter right now. Why not? And then, or did that work? I don't know if I hit it. Did I hit it? I must have. All right, so 23 days. It's 22 point something. So if you missed any part of that intersection stuff, I'll come around and help you. Okay? If there was something you didn't understand, I went too fast, yours doesn't look like mine, why did this happen, etc. Okay. Well, I don't know where you guys are in this, so use Canvas too. Okay. And I'll check homework in a few minutes. I don't know what I just went on.